Hey everybody, this is 11.3. We're doing missing sides. So last time we talked about finding a missing angle. Today we'll have everything except for one of the sides that we'll need to find. And then we'll also talk about solving triangles, and that will be at the very end, so don't forget that. So find a missing side. So this is one thing, is if we're trying to find a missing side and we have two of the three sides, then what we did in our 11.1, we could use the Pythagorean theorem. So again, the Pythagorean theorem is a squared plus b squared equals c squared. So that is an option if it came to that, okay? So just a reminder, this would be maybe like your a, this would be our b, and c is always your hypotenuse. So we'd do something like x squared plus 4 squared equals 9 squared, and then we just need to solve for x. So x squared plus 16 is equal to 81, and then we'd subtract 16. So x squared is equal to 81 minus 16, which is 65, and we'd square root both sides. So x is the square root of 65, and we could find it. So, and that's a choice, okay? Here's just another example. Here we're missing the hypotenuse. So we'd do something like maybe this is a, and this is b, and this would be c. So 5 square roots of 2 squared plus 9 squared equals, I guess, c. Or we could do x, I guess it doesn't matter. So again, when we're squaring everything that's in that parenthesis, we're squaring the 5, so that's 25. So we're squaring the square root of 2, which is 2, so that's just 50, plus 81 equals x squared, and that gives you 131. Square root both sides, and you get x equals the square root of 131. Hoping I'm getting this right, okay? So those are just your sides. That's what we're looking for. We're not writing down ratios or anything, so you don't need to like rationalize the denominator or simplify fractions or anything. All right? But what happens if you only have one of your sides? All right? So it says, what happens if you need to find a missing side, but we're only given a side and an angle? So that's what we're covering today. We're still going to use our functions. So sine of theta equals opposite over hypotenuse. So ka toa. Okay. And we're going to set it up the same sort of way. One thing you should make sure that you have it in degrees. We needed it in degrees for our last lesson, so hopefully you had it in this lesson already. But again, if you have a TI, then you'll probably need to go to mode. It's right next to your second button. If you're using like one of my Casios, then you'll probably need to go to setup. So shift and push setup. And you should see degree. Choose that. All right, so same sort of thing. We have our reference angle. Now we actually have its value. Here it's 49. And then we want to label our sides. So this is H, O, and A. But all we're really using is we have H and we need to find O. So which of these trig functions uses O and H? So we got so, ka, toa. So again, the only one that uses O and H is sine, so we have to use that. So here we've got sine of theta, but now we know what theta is. It's 49 degrees, is equal to opposite, which here is just x, over hypotenuse, which is 14. So this is the easier way, is if you have it set up like this, and you don't really have the choice. But here, all we need to do to get x by itself is to get rid of that 14. So we can just multiply both sides by 14, and we get x by itself. Now we just need to plug this into our calculator. All right, so I'm going to grab that. Give me 1 second. So 14 times sine of 49. So I'm going to switch to my calculator here, and I'll type this in, okay? So we got 14. You don't need to write the times between that and the sine, but you're welcome to. And then we'll do sine of 49. Close the parenthesis and push enter. So here we have a length of 10.6. We'll round to 1 decimal, okay? 10.6. So we'll go back here and we say x equals 10.6. And we should always have a look at our triangle. Does that seem like that could work? Yeah, I think so. The hypotenuse is 14, and x has got to be shorter than that. Okay, so that looks about right to me. And I think this says to the hundredths. I'm okay if you just do the tenths. All right, so now let's talk about b. Same sort of thing. Label our sides. This is our hypotenuse and our opposite and our adjacent. So again, we're going to use sine. So we'll do sine of 21 is equal to opposite, so x over 14. So same sort of thing, would multiply both sides by 14. And then would plug this into our calculator. So very, very similar, 14 sine of 21. So here I got 5.0. Okay, if I round to 1 decimal place. Maybe I should do hundredths place, but whatever. Okay, so let's give this one a try. So we're going to run into something that's a little different as we go along. So here we've got our hypotenuse, opposite, adjacent. So here we're using tangent. That's our TOA. So we'd do tangent of 38 is equal to opposite over adjacent. So x over 12.9. Again, would multiply both sides by 12.9. And we'd get x equals tangent of 38. Type that in. Here I got 10.1 if I round to 1 decimal place. Okay. And then we'll give d a try. Again, that's our reference angle, so opposite over adjacent. So here we've got tangent of 38 is equal to 5 over x. Okay, so here is an example that's a little different. Everything else so far, x has been the numerator, and now it's the denominator. Okay, so how I would probably recommend that you do this, and there's different ways that you could do this. You can do reciprocals, or you could do cross multiply. Oops, that'd be a 1 if we did that, so we could cross that. That would be an option too. What I would probably do is do the exact same that we did before. We'd multiply both sides by x. So then we'd get x times tangent of 38 equals 5. And then we need to get rid of the tangent of 38. Again, they're together. We can't separate them unless we use like an inverse. So we'll just divide. So the opposite of multiplication would be division. And we get x by itself. So x is equal to 5 over tangent of 38. Again, when we do this with our calculator, maybe we'd do 5 and then would use the division symbol and then do tangent of 38. Okay, so here I'll type mine in, 5 divided by tangent of 38, and I got 6.4. Okay. You might be able to go through this and kind of come up with like a shortcut to be able to do that, but I'm just going to do it like this, and if you kind of find a better way that works best for you, then that's fine too. Just make sure you show your work. All right, so here's just a couple examples like that. Here's our opposite over hypotenuse. That would be sine. Sine of 59 is equal to 19 over x. So we would multiply both sides by x. And then we would divide both sides by 19. Or sorry, sine of 59. And that would give us our x by itself. And we'll type that in, 19 divided by sine of 59. And I end up getting 22.2 degrees if I round to one decimal place. Okay. I think this is kind of the shortcut that I've seen that people have done before. Is so if we have sine of 59 equals 19 over x, really what you end up doing when you're done, we ended up getting x equals 19 over sine of 59. So if you notice, the difference between these two is that you end up just swapping the x and the sine of 59. Okay? So if that is helpful or helps you speed it up, as long as you make sure you understand how that's happening, I'm good. All right, last example here. Here would be hypotenuse, and this is adjacent, so we're going to use cosine. So cosine of 51 is equal to a over h, so 11 over x. So here we could probably do that here. 11 over cosine of 51. So we just swapped those two. Type that in, 11 divided by cosine of 51, and I got x is equal to 17.5. Did I write degrees at one of these points? I did. I'm sorry. That should not be degrees. These are lengths. All right, word problems, same sort of thing. Again, angle of depression, if this was me and this was you, okay, angle of depression is based off of the point of view. This would be depression. This would be elevation. And they are the same. It's just the point of view. All right, so let's do a couple examples of these. A meteorologist reads a radio signal to get information from a weather balloon. Then the last alert indicated that the angle of depression of the weather balloon, so maybe here's my weather balloon, okay, and if we were to draw a triangle, because they're asking for the angle of depression, we'd probably want to maybe draw it like this. This would be the angle of depression of the weather balloon to the meteorologist, so here's my meteorologist, it says is 41 degrees. And the balloon is 1,810 meters away from the location on the diagonal. So I put that in the wrong spot. Diagonal here would be here. Okay? They want us to know, to the nearest meter, how high above the ground was the balloon. So they want us to know what this is. So you could easily draw this differently if you drew it this way. That would be fine. You just need to realize that the angle of depression is the same as the angle of elevation, and you could have drawn it like this. Okay? Either way, we have the opposite side, and we have the hypotenuse. So that uses sine. So sine of 41 is equal to opposite over the hypotenuse. Would multiply both sides by 1810 and would get x by itself. So 1810 sine of 41 gives me 1187. Okay, so that's how high the balloon is above the ground. And I guess we should talk about meters. Okay, I rounded to the whole place, the ones place. All right, let's do another. A ladder manufacturer recommends the ladder be used on level ground and at an angle of 72.5 to the horizontal. So again, that's like your angle of depression. I'm trying to draw this, but I'm drawing it too big. Okay, so here's maybe my ladder. It's telling us that this angle to the ground is 72.5. Didn't draw that very well. 72.5. All right, and it tells you, or asks, at that angle, how far up the side of the building will the top of a 14-foot ladder reach? So this length is 14 feet. They want us to know how high it goes. So again, maybe label the sides. This would be our hypotenuse. This would be our opposite. This is adjacent. So we're using hypotenuse and opposite, so we have to use sine. Sine of 72.5 is equal to opposite over hypotenuse. So we multiply both sides by 14 and would get 14 sine of 72.5. And I got x is equal to 13.4. So that's how high it can go up the building. All right. I'll probably skip this one. You're welcome to give 5 a try, but for time's sake, we'll go on. All right, so solving a triangle. That means that you need to find the measure of every side and angle. Nice thing is that they'll give you half of it already. So here is an example. We already give CD. So CD is 18. We know that angle E is 27, and we also know that angle C is 90 degrees. So now we just need to find the other information. So what we covered today is finding a missing side. So maybe we'll find CE first. Again, using our reference angle, this is opposite over adjacent, which is tangent. So tangent of 27 is equal to 18 over x. Again, we can kind of use that little trick if you want, or we can just multiply both sides by x, and then we need to divide both sides by tangent of 27. So x is equal to 18 over tangent of 27. So I got 35, if you round to the whole number. Okay, sorry, it's not degrees. So our CE, which we just found, is 35. At that point, you could use the Pythagorean theorem to find the hypotenuse, or we could use trig again. So this is our hypotenuse. If we're trying to find, maybe I'll call it y this time. If we're trying to find h and we have o, then we would want to use sine. So sine of 27 is equal to opposite over hypotenuse, which is y here. Do same sort of thing, would get y is equal to 18 over sine of 27. So basically you do the exact same thing, it's just instead of using sine or tangent, we're going to use sine. And I end up getting 39.6. I guess maybe if I put decimals here, this would be 35.3. Okay, so we have that information. It's always best to use the information that you know that's 100%. If you are rounding, then that error can kind of go to everything else. So it's better to use the whole numbers that you already know. If we're trying to find angle D, well, we already know 2 of the 3 angles. So we could do 180 minus 90 minus 27. And that would give us 63. All right. So here's just another example. Our I guess I'll give that a try. If you feel like you're good, go on, but this one's a little different. We have 2 of the 3 sides, and none of the, or I guess we don't have one of the reference angles, so it's a little different, but same sort of thing. Let's find this missing side first. Let's use the Pythagorean theorem. So 2 square roots of 3 squared plus, maybe we'll call this b squared, equals c squared, which is 8 squared. So again, when we square this, we're on the right or left side, we're squaring the 2 and we're squaring the square root of 3. So 2 squared is 4, and the square of square root of 3 is 3. So we get 12 plus b squared equals 64. Subtract both sides by 12, and we get 52. And we'll square root both sides, and we'd get b equals the square root of 52. For this, I am okay. It's only when I'm asking for ratios that I want exact. If you want to have a decimal, I'm okay here. So the square root of 52 is 7.2. So we have this length, 7.2. And I rounded, so that's not exact. So we have kj, which is 2 square roots of 3, jl, so whether you write it as 2 square roots of 13, so if you simplified our answer here, we would get 2 square roots of 13, or 7.2. And KL we said was 8. So we have that information. We also know J is 90. So now we just need to use some trick to find the angle K and L. Let's start with K. Let's have this be our reference angle. This would be adjacent, and this would be the hypotenuse. So what uses adjacent and hypotenuse is cosine. So cosine of theta is equal to adjacent over hypotenuse. So 2 square roots of 3 over 8. Again, if we want to get theta by itself, we'd use the cosine inverse of both sides. And we get theta is equal to, we'll type this in, cosine inverse of 2 square roots of 3, and divide that by 8. So I got 64.3 degrees. And that's K. And then it would do the same with L, except we'd want to use maybe a different, this would be our reference angle. So I'd maybe erase my A, I'd erase my H, because now this is H and this is the opposite side. Again, we want to use our exact answers. We probably wouldn't want to use the 7.2. So here we'd do opposite over hypotenuse is sine of theta is equal to opposite over hypotenuse. Again, would sine inverse of both sides. So again, that cancels. Theta is equal to sine inverse of 2 square roots of 3 over 8. Again, this is very similar. It's just we're using sine inverse instead. So you could even just go back and change your cosine inverse to sine inverse. And we get 25.6, or 7. I guess you could also say we have the 2, we know that 180 minus those 2 would give us our answer too. So maybe that would be the easier way. Okay, and that's it. If you have any questions, please let me know. We'll see you later.